Okay, so question number 5, we are given a differential equation, dy over dx is equal to x over y. Okay, differential equation. And we are told, which is very crucial, y cannot equal 0. Okay, so first step is for the slope field given, we have to draw the solution curve at 2 points, at 3, -1, and 1, 2. So you can see they give us the points here. So there's 3, -1, and here is 1, 2. Okay, so if you look here at the diagram, we have the solution curves drawn in. And the first solution curve going through the point 1, 2, you can see you follow the slope fields. Basically, your particular solution is going to be tangent to those slope fields. Now, when you draw the particular solution using a given slope field, it's very important that you follow the given slope lines and you extend to the boundary of the slope field. So make sure you go all the way, so you can see here I went all the way to the end, all the way to the end. Now the second piece, this is the one that's most missed. Now you notice on this function, so you follow the curves, you're tangent to the slope field given. Now we are told that y cannot equal 0. So at that point, y is undefined. Now in order for a function to be differentiable, it must be continuous. So you notice from going, as I approach the x-axis from the right, it's continuous, 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 and at that point then it no longer remains to be continuous. So then my differential function, the solution given this differential function, will then end there. Now I'm going to clarify this a little bit more by some research I've done. Actually, this is just the solution. So I asked a question, and this is what I was told, and given more clarification. So the domain is going to be the largest interval on which both dy and y are defined. So we notice that the dy dx is not defined in this example when y equals 0. So y cannot equal 0. Now, this was a different scenario that I asked about before, but you can see if I was given this differential equation, 1 plus y over x, in this example, x could not equal 0. So it's undefined there. So therefore, the domain cannot include x equals 0 or anything on the other side of it, because then it's not continuous. So in this example that we're looking at, y cannot be equal to 0 or anything on the other side of it. Now, if you'd like to see some more examples and more clarification, here's a website that is provided by AP Central that gives quite a few more examples, you can see other domains for differential equations. Now let's continue and finish solving this problem. You had to write an equation of a line. Okay, so we want to find the equation of the line at the point 1, 2. So in order to write an equation of a line, we need a point, which is 1, 2, and we also need the slope. Well, we use the differential equation, which says x over y, so it's going to be 1 over 2. So the equation would be y minus 2 equals 1/2 times the quantity x minus 1. Done. Now that was worth 1 point right there. Okay, now for part C. Now A was worth 2 points. You got a point for each piece of the particular solution drawn correctly. So C now is going to be worth 6 points. And they say find the particular solution y equals. So in other words, you are given the differential equation, and now they want you to solve for y. So now we're going to separate, integrate, add a c. So I'm going to separate first. So y dy equals x dx. So that is worth 1 point. Now I'm going to take the integral of each side. So that's integrate. So I get y squared over 2, sorry that 2 is messy, equals x squared over 2 plus c. Now that's worth 2 points. Now we're going to use the value given, which is 3, -1, and we're going to solve for c. So separate, integrate, add the c. Let's find that c now. So we have a -1 squared over 2 is equal to 3 squared over 2 plus c. So I have 1/2 and I subtract 9/2, so I get -8/2, which is 4. Fantastic. So at this point now, I'm going to go ahead and replace c with -4. So I have y squared over 2 is equal to x squared over 2 minus 4. Now we have to continue solving for y, so we'll multiply both sides by 2. Y squared equals x squared minus 8. And now we're going to take the square root of both sides. The square root of y is equal to the square root of x squared minus 8. And we know that the square root of y is the absolute value of y. Okay? Now this function then could either be the positive square root of x squared minus 8 or the negative square root of x minus 8. But since the solution has to go through the point 3, negative 1, where the y value is a negative, we must then define this function to be the negative square root of x squared minus 8. Now, so that right there was worth 5 points. Separates 1 point, integrate 2 points. And then solving for y is another point. Using the constant is another point. And then using initial constant summary is another point. So that's 5 points. Now we have to find the domain. Now for this domain, we know that the radical can never be less than 0. So x squared minus 8 must be greater than 0. So therefore, x squared must be greater than 8. And then I take the square root of both sides, and I get x is greater than the square root of 8. So then the domain for this then is x must be greater than the square root of 8. There you go. I hope that answers your questions.